Hello everybody, welcome to the Block Talk Session 4 by OpenCoin IT Raurkela. And in today's session, we will be discussing about Web3 development. This session will be taken by me, Harsh Kumar Verma. In today's session, we will be discussing about what is Web3 and Web2, just getting a revision of it, as well as I will talking about some dev tools and Solidity basics, and we'll also be coding our first smart contract. So without wasting any time, let's start. So we have already discussed what is Web2 and what is Web3 in our previous sessions. I'm just going to give you an overview. So think of Web2 as a centralized server or a centralized database server where a single server serves every person and every user that has access to it. You can like Netflix, Facebook are prime examples of Web2 services, and they are generally user or corporate control. Group of people or a single person has the control of the system, and it gives you you have to trust them that they will protect your data securely. Monetization basically occur through ad-driven services, whereas for Web3, they are decentralized users. People have access, there is no central access. Everything is distributed among people and controlled by them. Uh, People are responsible for their own data and privacy, as well as control is basically interact with blockchain through smart contracts and DAOs. Money is usually made through decentralized applications and tokens. And for database, we basically use chain itself and IPFS. IPFS stands for Interplanetary File System. Okay. Now we have just revision ourselves. Now let's move forward. So why should we use Web3? That's a basic. So that's a fundamental question that should arrive in your mind. So think of it like Web3 provides you peer-to-peer connection. You are able to connect to people you want to deal with and transact with or do any business with. You don't need any intermediaries for services. There's also few intermediaries, as I said, linking to that only. You can just try to connect to the partner or business partner you want to operate with. And transparency and trustlessness, since you don't have to put your trust in anybody because you are responsible for your own data and management. You don't have to be on a promise, and everything is transparent. You can always track what is going on the Web3. And obviously permission and innovation, there's no restriction on innovation. You can use anything on a blockchain and create something from it, or anything from the scratch itself, because that's all that was the meaning of the blockchain, to create something fundamental. Now let's start with the main part of our session, smart contracts. So just as I have told you before, a smart contracts, think of smart contracts as a set of code that is deployed or stored on blockchain, and it runs automatically when agreement of certain conditions for the contracts are met. Let's say for a lottery contract, if it has certain money and certain amount of users, it will run itself and pull out the lottery, something like that. Now let's talk about some development tools that we use when we starting with the Web3. When we start with Web3, so there are popular development tools like Hardheads for local development. Like I want to code on my own machine, I will use Hardhead. As well as there are online engines like Remix ID. We will be using Remix in our today's session, and there's Ether.js for all the JavaScript people out there. It provides basically your Web3 environment for a Web3 environment with JavaScript too, so that you can start coding on it. There's also MetaMask wallet, which we have talked about in a previous session. You can just go and visit it. And node providers like Alchemy and Infura, as well as local blockchain hash networks like Banachain. These are technology that are popularly and must use when you are developing a smart contract on your system or on online medium. There's also popular languages that we come across when exploring Web3, like Solidity for Ethereum. We are going to explore Solidity in today's session only, and learning some basic coding about it. There's also Rust for Solana, that is extremely Rust is also many things, but for Web3, we generally go with Rust for Solana. And there's also a new language called Move for Sui that is really fast blockchain network. If you have explored something, there's also some complementary language that we use with them, like JavaScript and TypeScript to write compilation code and scripts and deployment builds. There's also Go. You can write entire blockchain with Go, and Cairo for a better object-oriented and old traditional way, as well as but alternative to Web3 in Python, a Viper. Now that said, Anna, we have just known what are development tools and how many languages are there. There are more tools, you can just go and explore and you will learn more about it. And now with that said and done, now let me just first tell you what Solidity is before we start writing our first code. So think of Solidity is like Solidity is a high level statically typed program language. It is that is mainly created to develop smart contracts on Ethereum network. So yes, that was it. It is a high level language. It is statically typed. Means that once you set any variable and define it, you cannot change it later on. It is for Ethereum blockchain. Now I want you all to, I guess I want you all people to go to your browser and search Remix its IDE. Go on the first link you see, and then go to the IDE part. It should pop up a IDE for you. Clear this home, and this is the Remix IDE that is used for developing smart contracts on online medium. Go to the contracts and let me just clear this files. I will create a new file. Let's say it hello.solve. Now we have created our first Solidity file, and now let's first initiate our file. So go to the value.sol and let's copy this license. We are using this license is like an identifier that just drop some unnecessary errors that we won't want, that we don't want in our error, in our contract. Now let's write our first line of code. So write pragma. See, pragma directive defines, pragma is a directive that defines the version of your Solidity file or the version of our contract, which Solidity version it is using. So pragma, Solidity, we define the language, and now we set the version. We can either set a specific version or we can set a range of version. So let's go with it. See, wait a second. So now we have set our specific version for it. Now it will be it is explicitly using 0.8.0 version of the Solidity. But we can also set a range of version like our Solidity file version should be greater than equal to 0.7.0, but it should be less than 0.9.0. Any version of Solidity between these two will be used. Now let's write our code. Now let's initiate our contract. So any code in smart contract authority goes under this contract directive. Basically, what is it? It defines our contract. Like this is the contract. It explicitly mentions it. Like when you don't have to write a specific function at it to define this is our contract. This directive automatically defines your contract for yourself. You and let's name our contract. Hello. This is our contract. Now let's create a variable so that we can like we need to have something in our contract. So let's create a variable and it will be a string public and greet. It will greet you. Great. And what will it say? Hello Web3. Now we have wrote our first set of code in our Web3 and created a like we have AI actually created a smart contract. This is the contract. And now go to Solidity compiler and set it to auto compile. It will automatically compile your code. You don't have to go again and tap on this button. And then go to the deploy. See, Remix already provides us some free Ethereum or account or testnet accounts so that we can deploy and test our smart contracts as well as you can use your own MetaMask account so that you can explicitly use mainnet Ether to test your smart contract on the real net. For now, we're going to use the free net itself, and it has 100 Ether for us. And now we're going to deploy the smart contract that we have created. Now let's deploy it. As you can see, we have a transaction. Let me see. See, when we deployed our contract, it made a transaction on the Web3 or the blockchain. We got the transaction hash and block hash for our smart contract, and our contract is officially on blockchain network. And here we have can see a showcase of our contract, and we are able to interact with it. Since I created a state variable that is explicitly public, wait a second. It explicitly public. I am able to interact with that particular variable. So what we create a grid. We our variable has a name grid and it has a value web3. So when I click on this button, it should give us our value, and it is giving our web3. And you can see when I click on this button, it also created a transaction here. So what can we take it from here? every interaction on the blockchain network on the or whenever you are interacting with a smart contract, it is transaction. Every interaction on the blockchain or Ethereum or any blockchain network is a transaction. That's how you operate. That's how you interact with the blockchain. You make a transaction, some things happen. That is how it works. Now let's get back to our slides. And yes, this I have just this I have said. We have written the code, pragma defines also reversion, contract we defining smart contracts, and we have created a smart or state variable. Now I will talking about some functions and features we are going to implement in our final contract that we are going to create. So I will just covering the theory part as fast as I can. So we can start coding our main smart contract. So first of all, let's talk about data type in Solidity. So in Solidity, basically, what do we see? They are very similar. You can find very similar data types in Solidity as just like you found in other languages, like integers, unsigned integer and integers. Basically, think of unsigned integer as positive numbers from 0 to 10 to the power 256 or like that, as well as think of integers as signed integer. It is for the positive values as well as it contains the negative values as well. There are for booleans, for Truthian and false functions. There's also strings, arrays, and enums that we have heard about in other languages. There's something unique that I want to talk about, that is address. So what is address? Address is the, let me get back to the remix. As you can see here, this, let me just paste it. This thing, this this is your address. This is your Ethereum address. This is your account address as well as your transaction. Every transaction we make, it also has an address. This is what it is. Our address. So we have a specific data type for storing our addresses in the Solidity function. It helps us a lot, and you can say it reduces a lot of pain. It reduces a lot of pain for developers for developing smart contracts. We also get structs and mapping. Think of structs as custom data type where you can put or group multiple variables in it, and think of mapping as a key value pair function where a key is introduced that points to a particular value in a one-on-one basis. We also have some global variables to point out who is interacting with our contract. We basically explicitly use msg dot something value to point out that msg dot msg dot basically points to the interactor who is interacting with the contract at that moment. Now there are also customer functions. Customer function can you think about special functions that automatically initiate themselves when a contract is deployed. And there are also view and pure function. View function are basically we use when we want people to read our function. We don't want any modifications to be made in there. And there are also pure basically are input and output function. We give them some input, it grants us some output. We cannot read those functions, we cannot modify those functions. That's what pure does. Now there are also events. Think of events like console.log on the JavaScript. We want to store some data. Like let's say I am giving some money to you on the blockchain. I want it to be stored. So I will use event. It will log that data on the blockchain itself. And there's also require statement. Since we lack if and else statement in the Solidity language, we have require. What does require do? Require checks the condition. If a condition is met, it will let the function continue. Otherwise, it will cancel that transaction. We also have modifiers. Most modifiers are required are generally used side by side because they are a good, like I can say, they are really usable with each other. And modifier basically what does it? Modifiers are used to create conditions that we can apply on other functions. Let's say I am creating 5, 6 functions and all of them have same conditions. So I will create a modifier, then writing, then explicitly mentioning the condition in each function. That will increase the line of code and overall cost. Now, before we start coding our smart contract, let's discuss about data locations. So think of data locations in normal way. There's also storage and memory. Storage stands for persistent data, or in a hardware term, if I have to explain, think about storage as ROM data, and memory as a RAM data. It temporary storage. As long as contract is being executed, it will store that data. There's also car data that are basically function arguments that are stored while function is being processed. Now we have covered the basic, or we can say theory part of Solidity. That much you have learned that much that you can create a small contract. And for today's session, we are going to create simple bank. Now, when we think about simple bank, what are the features that a bank needs? It needs to have a deposit. It needs to have a deposit function. We are able to give it money. It should also have a withdrawal or transaction function through which we are able to take out some money, and we should also be able to check our bank balance. We should know how much money we are holding. And let's say, and this bank also has a owner, so owner should be able to see his own money as well as how much money his bank is holding. We are going to use remix only, and I'm going to code this from scratch with you people. So try to keep up with me. I will explain every and each step while doing this. So first of all, go to the remix ID and go to the files. I'm just going to delete this. Sorry, and I will create a new file. We will name it bank.sol. And let me just copy this first three lines. These first three lines are going to be same in every smart contract you come across. The version may vary, but everything else will be same. Now let's initiate our contract. So our contract will be we will naming it simple bank. And now let's think about it. What do we need in our bank? We need users who will be using our account, and there should be an owner of this bank who will be owning the bank, managing everything. So who let's first create an owner. Our owner be an address type, because on Ethereum, you can say on Ethereum addresses point to the person who is owning or interacting with the contract. They are the person. Ethereum addresses are the person, and it will be a public function. Everybody should know who the owner is and owner. And let's go ahead and now let's think about it. I can either create an array. Can either create an array where we will store some data points, and whenever we want to like I say, like whenever I want to make a transaction, our algorithm will run and search for them in the array. See, if our array is small, it works fine. But as time goes and user will grow, it won't be feasible. It will cost us something. Remember, on blockchain, uh, every process, every bit of code must you money. So we have to be efficient. So what we will be using? We will be using mapping. Mapping basically are key and value pairs. Like say key and value pairs. So what word does maybe do? We will pointing to the key who will be our user, and it will automatically give us its value. It's time efficient, it is fast, and it is cost effective. That is why we are going to use mapping. So let's create a mapping of our accounts and their balances. So we'll write mapping. Now our key will be of address type, and our value will be of unknown type. We will name these mapping as balances. Now, with that said and done, we have created the type of data, like type of variables we need in this for this smart contract. We also need to create some events because we need to log every data, every deposit and withdrawal that is being made on our blockchain. So we'll create some events, event, and we will name it deposit made. Deposit made, and basically it will be will be showing us the who is depositing the money. That is address, indexed, account, who is depositing the money, and how much money he is depositing. Let's just copy it up. Then we also create it for withdrawal. Yes. Now, I see what's happening. And now let's think. We have create events. We have our variables. Now let's also create a modifier because we need that only owner will be able to see the total bank balance. So we need to create a modifier as well. So write with me modifier. It will be we will naming it only owner. It will be a function that has a require statement. And what does it will say? It will say msg.sender. Now look at here, msg.sender. Msg.sender will be pointing to the person who is interacting with our contract. That is what it will be showing us. Msg.owner should be allowed. Otherwise, if msg.sender is not there, it will throw us an error. What does that error will be? It will be error, but it will be saying not allowed. Now that is how it works. Now we have created placeholder. Since it's a modifier, we need to have a placeholder for it. Now we have created a modifier, and Now that we have all the basic setup, we have created our variables, our events, and our modifiers. We will start writing our actual contract. So let us first create a constructor. We need to set who the owner is. So we have to create a constructor. So it will automatically set who the owner is by whoever is interacting the contract at first. So it will be construction, and owner will be the person who is deploying the contract. That is msg.sender. He is the person who is deploying the contract. Now with that said and done, let's write our first function, a deposit function. So it will be function, sorry, function deposit, and we are not going to give any argument because there is nothing existing on the chain as of now in the account. So we don't need any argument here. So we'll just pass it on. It will be a public function because everybody need to submit the money, and it will be a payable function. Why payable? Because we are submitting, we are interacting, we are deducting money and shifting it somewhere. So we need to make it payable. It will cost so that it will take what is it will take money to interact or कैसे ना Ethereum or Ether to manipulate it. Now let's set a requirement. We need users to give us some money. We can't deposit zero money, $0 or 0 rupees, right? So we have to state a condition for it. We will be using require for it. It will be require, and we will be saying basically saying msg dot value. See, msg dot value is another global variable. It basically shows the amount of money the person who is interacting with it sending to us should be greater than zero. If the money person send is greater than zero, it will pass. Otherwise, it will say not enough money, and that is how it will work. And let's give me proper idea, proper identification. And yes, now we have set a condition. Now let's transfer the money in our user's account. So we are going to point to the key. So who is going to be our key? Balances msg dot sender. It is the key that we are interacting with. And what I am going to say, it is pointing to the amount. See, it's the key and it is pointing to the amount. So we don't need to actually mention it. So don't get confused that is we are calling an address. No, we are calling the amount that particular address is holding. And then we just add the amount of money he is sending to his account. If he doesn't have an account, it will automatically create one. So we don't need to create a function to create an account itself. If we are using array, then we have to do that. Now we will emit this. Do that. And now we have created a function emit. Like we have need to log the data, right? We have to log the data that to show such this account has sent us this money. Okay? So we are going to use our events, and deposit made is the event we have created. Now account, which account? MSG to sender. He is the account that is interacting with the contract, and how much money he is sending? He is sending MSG dot value money to us. Now we have created a deposit function for our bank. Now we are depositing money. We also need to take out the money. We need to create a withdrawal function also. So let's create a withdrawal function withdraw. I will just name it withdraw. Now this will take in argument because we are interacting with already existing amount that is on our account. So we need an argument of ourselves that will interact with that. So we will be creating a variable that will be an unint type variable that will name amount. It will be a public function. And now let us write a requirement for this too. What do we require here? See, we want if I only have 100 rupees in my account, I cannot take out. We can say 200. I can only take out 100 at max. So we are going to set that condition here. We'll say require uh, balances, like how much money our account has, balance of sender should be greater than or equal to amount that I am asking for. And if it doesn't have, we will say not enough balance. Now with that said and done, we have created uh, our conditions. Now let's first deduct the money from the account. So the starting information balances msg dot sender minus equal to the amount that he or she is asking for. Now Oh, sorry, sorry. I have to use square brackets here. Yes. Now, see, we are deducting money, but we are not giving to the user. We are just deducting money from the contract. Now we have to pay the user this much money. So we have to create a pay. We have to pay it. So we will explicitly mention that who we are going to pay. So write payable. And who are we paying? We are paying MSG.sender. And how much we are paying? Underscore amount money we are paying to him. Yes. Now, since now withdrawal is being done, we also have to log it in on the blockchain itself. So we can have amount. So we write emit withdrawal made, withdrawal made, and who is making the withdrawal? MSG dot value is making. Sorry, MSG dot sender is making the withdrawal. And how much he is withdrawing? Underscore amount he is withdrawing. This much money he is withdrawing. Oh, sorry. Yes, this much money he is withdrawing. No, we have written a basic idea of our smart contract. We are able to give money, we are able to take out the money, but we also have to check the bank balance. So we will write a function for bank balance. It will be fairly easy. It will be function get balance. It won't be we are going to read the function. It will be a reading function, so we don't need any arguments. It will be a public function, and we will set view so we can avoid anyone making any changes on these functions, and it will be returning us an uint. And what is it is going to return? It is going to return the amount of balance we have. So balance is bracket msg.sender. As I have been telling you again and again, this is the key and it is pointing to the value that we have. And what value we have on it? Our amount. Now, kind of like all the user functions created, but as a owner, I should be able to know how much total money my bank holds. So now we are going to use that. We are going to create that function. So it will be another function get bank balance. It will it as like always it is we are just reading the function, we don't need any arguments. It will be a public function. That's it. Because yeah, we need people to interact with it. Like the users should be able to interact with it. And it will be a view, no modifications we needed. Now we are going to use the modifier that we have created. It will be an only user modifier and what can I say, and it will be returning us an on it. And what is it? It is going to return us address this. Now address dot this is pointing to the address of the contract itself. And what it will be giving us, it will give us a balance. Now with that, we have created our simple bank. Now let's see if it is compiling good. Yes, it is compiling good. Just to make ourselves sure, we will compile it again, and now we will going to deploy it. So if I am right, this will be the owner of the account 5B3 EEDC4, right? So let's deploy it as the owner. Now I have deployed this account. As you can see, we have deployed our account. Let us give some money. So go to the wave part here and change to ether, and I am going to give 10 ether to this. Oh, sorry, 10 ether to this account, and I'm going to deposit it. See, I have deposited 10 ether here. Now I should also be able to withdraw it, right? So I'm going to withdraw to it. See, we are at see withdraw it generally taken in always taken in this. So we have to keep the units in the caps in check and then withdraw it. So I have taken out this much money, 0.002 ether, and I am able to check the balance. Now let's see for accounts. Let's come with tons of different accounts, this account, and it will also give 5 ether to this bank. Now we have 14, you can say 14 ether on this bank as of always. We are able to see this balance because as a feature of remit system, it shows the total amount of money our contract is holding. But when you are creating a blockchain, or you can say creating an application with it, you will hide it, obviously. Now it should also be able to withdraw some money, right? So let's try it. Yeah, it is also withdrawing, and it should also be able to check the balance. See, it is showing its own balance only. It is not showing the owner's balance. We are only able to see our own balance, and yeah, we can also access our owner. But now let's see it. When I try interacting with this button, get balance to check the whole balance of the of the bank without being the owner, what it will say? It will throw us an error. What will it say? Not allowed, because we are not the owner. But when I go here and shift to the original account, which deployed the contract, and try to call this function again, it will pass, because we are the owner and we are able to see how much total money our contract is holding. So this was your first smart contract, a simple bank. You can make it, you can enhance this code base. I will be providing it to you in the PPT itself, and you can code this and improve this contract itself, or either you can try create something new from the knowledge that you have gained through this session. It was really fun teaching you people, and now let's come back to our PPTs. So that we have now created our smart contract, and I just showed you how you can interact with it and how does it work, and a small idea of solidity development. You can just go try with yourself, try to recreate this contract or try to make something new from the things you have learned. Now, before moving forward, let me share you some personal advices or advices that beginners make when they start with Web3, not testing properly. Like when you are writing your contracts, if you are not going to the edge cases, you are just thinking, using some basic examples, and if the code is running, you are being happy with it. No, you have to make sure that your code is efficient for multiple edge cases, and it is not too expensive. And that's come to our next point, cache inefficiency. So see, every, as I have told you before, every transaction or every interaction on your smart contract is a transaction. You are paying money for it. If your smart contract processes cost too much, it will be unusable and nobody will is going to use it. So you have to keep in mind that your contract is less efficient. So that is a common practice. You have to keep your code clean. Try to write less repetitive code. Organize your variables thoroughly. Write comments and documentations, and security oversights. Now, these are the things that you should remember when coding a Web3 contract. Now, I will also showing some learning material. First of all, you can use YouTube. You can actually learn whole Web3 on YouTube itself. There are many creators that have created good quality content. You can go check it out. And here's the playlist that I personally recommend. Let me just zoom up. That you can go and follow it for, as I say, for getting started with Solidity and Web3 in general. There's also a very popular platform called Cypher of Draft where you can get best free material to get started with Web3 development itself. Must check it out. A must check website. If it doesn't matter, you're not going to follow it, but just check it out once and try to learn something from it. It is a really good platform. And obviously, you can never go wrong with the docs. With that, I have also provided the code of the content we have created, so you can just try to replicate it or enhance it yourself. With that said and done, our session is over, and you can join our open code community, uh, open community at Andrew Orkela. It was pleased taking this session with you.